Oops, in the delta development exercise there's an error. Well, that's good practice, it's a good exercise how to deal with errors. It appears that after 70% of the runtime, it gives an error, water level too high. So if this happens to you, the first thing you should do is take a look at the tree.diag file that is generated by the model. It's basically what the model feeds back to you as information so that you can analyze what the model is doing and what is going well and what is causing errors. So I'm opening the tree.diag file in the text editor. And it may be a very large file sometimes, so it says everything. The flow version it's related here, and here you see that there's a lot of warnings, which is not bad. I mean, but in the end, you see here that the water level change is too high, and it gives you a little bit in the following point. So it gives you the information that the MN coordinate is 102.51. So M is 102 and N is 51. So in the GUI, I'm going there to see what cell that is. Also in QuickPlot, I can plot my bed level developments, and they all look pretty nice actually. So nothing happens really in this. And this is then the delta development. This is the last output time, but it means not necessarily means that it gives you the error, because the map file has this dedicated 1 hour time step that it only gives output, and maybe it doesn't provide the error exactly on that time step. So I'm going to look for the cell, and the cell appears to be, you can see here very clearly what the M and N coordinate system is. So I'm going to 101 and 51, and it appears to be a cell at the boundary. So something goes wrong at the boundary. And if we look at the erosion of the bed level developments, I see here that it is quite shallow, and I don't fully trust it. So what could happen is that because of the erosion and sedimentation patterns, there can be a dry cell that can evolve. So a dry cell means that cell during a time step, the bed level change is so high that it is never flooded again. And when it is never flooded again with water or by water, and then it cannot erode anymore, and it sticks out as a kind of fixed concrete cell. And that can happen because the morphological factor has an increase of 100 that we apply over here. And then suddenly you have a concrete pile, and when that is happening at your boundary, and that is, I think, what is happening here, then you get an error, because your inflow boundary should always be wet. It cannot be a dry cell. So that is my analysis. So, but I also have a solution for this, and that is the following. Provide you with a if we going to assess dry and wet cells, for example, here we have the yellow part is dry cell, and here we have a nice channel or a river discharging into the ocean, and that is all wet. So we have wet cells and dry cells. Now there is an option to say, like, for example, if you calculate the erosion in a wet cell, which is the red part over here, you don't assign that erosion to the wet cell itself, but you assign it to the adjacent dry cell. So the wet cell doesn't erode, but it is that's a kind of bank erosion mechanism. So the dry cell lowers as a result of erosion in the wet cell, and that process continues until the dry cell also becomes wet. And this prevents basically these very dry cells, these concrete pillars in your model. And if you do this, they can always erode, and the morphological runs are more smoother and are more stable. Well, how to do that? You have to set your theta SD to 1 in the morph. So I'm going there. In the morph file, I select it by text editing, and the theta SD is 0 here, and we have to set that to 1. We have to save that. And I'm sure, because I tested it, that if you run this model like this, you have a very smooth and stable morphodynamic model. So good luck with that.